All right, so when we do A, we're going to do it out of order because I want to be able to demonstrate using one of the right-hand rules, so we're going to do A2. So A2 says if an electron in an electron beam experiences a downward force, so we're going to write our given, we're going to write our find, just like we do with every other question. So they're telling us the force. So the magnetic force, and just because we're just starting this, I'm going to call it F magnetic, is 2.0 times 10 to the negative 14 newtons. Remember, force is always measured in newtons, and force is a vector quantity. That means it has both magnitude and direction. So I have to write the direction. So they told me this force is down, and I'm going to write that down because that's going to be important when I'm using my right-hand rule to find the direction later on. Then it tells me while traveling in a magnetic field. So the magnetic field is B, and that's 8.3 times 10 to the negative 2 Tesla. And they tell me that this magnetic field is going west. And now that's also important because magnetic field is also a vector quantity that has both magnitude and direction. And what is the direction and magnitude of the velocity? So I want to find V. V is still velocity. But I also need to find the direction. So I need to find the magnitude and the direction. So I'm going to use my equation to find the velocity, the equation that B is equal to F over QV, and then I'm going to use my right-hand rule to find the direction. Now, before I go on, I need something else in my given. So they told me it's an electron, so I know that the charge of an electron is negative 1.6 times 10 to the negative 19 coulomb, because we've done that before. So what I'm going to do first is I'm going to rearrange this equation to solve for V. Okay? So you can do it in little steps. You can multiply both sides by this. Well, since I want to solve for V, this needs to be in the numerator all by itself on one side of the equal sign. So I can say BV is equal to F over Q, but I just want to solve for V. So I'm going to say V is equal to F over QB. So if I don't want to make an algebra mistake, I'll do it in 2 steps. Now I'm going to substitute in my values 2 times 10 to the negative 14 newtons divided by 1.6 times 10 to the negative 19 coulombs, and then 8.3 times 10 to the negative 2 Teslas. Now, if I was doing this in my calculator, I'd probably, since I have these exponents, I'd probably do the numerator first and write that down, and then do it in 2 steps. So when I do the math, the velocity comes out to be 1.5 times 10 to the 6 meters per second. But this is only part of my answer, because what happens is that they ask me for the direction, and velocity is also a vector quantity, has both magnitude and direction. So now, here's the thing. If I'm doing something and it's positive, like a proton, I'm going to use my right hand. If I'm doing something that's negative, or they're telling me, instead of the current, they're telling me the flow of electrons, I'm going to do my left hand. So in this case, because we're doing an electron, we're going to use our left hand. All right? I think it's easier. Some people use the right hand and they say, oh, it's the opposite. And I think that's confusing. All right? So now what we're going to do is the force is going to be our palm. Now this, they tell us, goes down. So I'm going to put my left hand, I'm going to put my palm down. Then they tell me that the electric field, this my fingers, this is going to go west, and then my velocity is going to point whatever way my thumb is pointing. That's going to tell me the direction. So what we're going to do now is we're going to take our left hand. The palm is going to go down. So my palm is actually going down. Now remember, I want my thumb to be perpendicular to my fingers. All right? So my palm is going down, but now my fingers have to go west. So if I use my standard north, south, east, west, I'm now going to take my hand, my palm is still down, and my fingers are going west. Which direction is my thumb pointing? North. Okay? So now this answer is north. And that's it. So that's how we use, there's 3 right-hand rules. That's how we use it to help us find the direction. Okay? All right, let's very quickly look at, we'll very quickly look at B1. So for B1, I'm going to read the problem. I'm going to write my given and find. Okay? So it says a 6-meter wire, so they're telling me the length. So L is equal to 6 meters. Okay? They're telling me that I is equal to 7 amps. And they tell me this is in the plus X direction. And then they tell me that F magnetic is equal to 7 times 10 to the negative 6 newtons. And this is in the negative Y direction. So again, I'm going to use my right-hand rule to find the direction. So here we're going to use the equation B is equal to F magnetic over IL. Now the way that I remember it is, I remember that F is equal to BIL, because that's an easy way to remember it, like F is equal to Bill, right? But I'm going to rearrange it to solve for this. So I'm going to have 7 times 10 to the negative 6 newtons over 7 amps times 6 meters. When I do the math, B comes out to be 1.7 times 10 to the negative 7 Tesla, but that's only the magnitude. I need to also find the direction. So what I'm going to do is, to help me with my rule, I'm going to kind of draw a picture before I use my hand. The I is in the positive X direction. The F is in the negative Y direction. And then my B is going to be in the positive Z direction. Now we'll practice this in a second once this is done using our hand to see the right hand rule. Okay? And we're going to